Students, welcome to a little overview of Lesson 14 and what I call overview and advice. Lesson 14 has to do with the central limit theorem and then applying it to finding the means of a population. It's really, really neat. So here we go. Okay, here's the problem. The percentage of fat calories that a person in America consumes each day is what? Normally distributed, okay, with a mean of about 36. So this is talking about mean 36, and a standard deviation of about 10. Okay, suppose 64 individuals are randomly chosen. Okay, so now we're talking about 64 individuals, and we want to know something about this group. All right, so the first one is find the probability that the average person consumed more than 25 grams. Okay, that's a good question. And then find the first quartile for the average percent of fat calories. Now, this question just has to do with the 64 people. Okay, just the 64 people, not the entire population. So keep that in mind. We'll come back and we'll look at that problem later. Now, how are we going to do that? We're going to use what we learned from the central limit theorem, and let's explain that maybe a little bit. While we're talking about this lesson, we have, remember the requirements for it to open up. You have a good little introduction, and you have these videos. I know that you may be busy and you may not have time to sit down, but sometimes watching the video or making yourself sit down and watching the video really helps. Then, of course, you have the exercises, which I got that question out from, and then you have your solutions, and of course, then your quiz. So this is the tasks for Lesson 14. The reason why I'm not putting any more of my resources in here is because I think it's important to send a message, one, to the students that working through the material that doesn't need a lot of extra information. What is the minimum I need to do to get through the course, okay? So this is for them. Also, the E-Core people really don't want folks messing with their tasks because this needs to be similar for the next group that takes it or someone that needs to take the course again. So what I do is I supplement this list with this video, for example. Hope that made sense. All right, so now what we're going to do is we're going to take a moment and look at what I call the notes, okay? So here's what's happening. I have a population of people that it has something to do with calories. That's everybody. In the population, there's the mean and the standard deviation for the number of calories. Now, honestly, most of the time, we don't know that information about the population, but we are very interested and would like to know that information. So what we do is we get a sample. Now, when we say a sample, we mean a random sample, okay? Of course, remember the standard normal curve. It's a mean of 0 and standard deviation of 1, right? Okay, the standard normal curve. All right, so what we do is we get samples. So I'm going to go to the population, and I'm going to, I don't know, I'll take like 10, and then I'll measure the mean of that. Then I'll do another 10, okay, and I'll get the mean of that. What the central limit theorem says is if I kept on doing this, let's just say I did this 15 times, what would happen is I would have some averages that are high and some that are low, but most of the averages would be in the middle. And believe it or not, that distribution would look like a normal distribution. Now, the key is, let's just say if my population was a normal distribution, I could probably start seeing that soon. But we're just going to say 30 samples, okay? And that will help us out. Just remember that number. All right, now another thing that's really neat about the central limit theorem is that the mean of these samples, the mean of the samples, so that would be mu x bar, believe it or not, is the same. That value is the same as the mean of the population. That is too cool, okay? And also, this little, the standard deviation here of the sample, this is what's called the standard error of the mean. So again, I'm right here. And the way to do that is you use this formula, okay? So the standard deviation of the sample is going to be the population standard deviation divided by the square root of n. All right, like I said, we don't always know the population info. When we do, we use this. When we don't, we do something else. We'll see later. So sigma x bar is called the standard error of the mean. So keep that in mind. Now, the sample standard deviation is smaller than the real standard deviation. That makes sense because if I'm taking samples of, let's say, what did I say, 10, 15, okay, over here to the side, I'm very rarely going to get the smallest or the largest. So these values that I'm using to make this chart here, okay, to make my standard normal, are not usually going to include the far out values, so the standard deviation is going to be smaller. That's all that means, okay? And here's what's really neat. The sample mean for a skewed population, again, there's two types here, for example, a uniform, which we'll see in a second. But even if the population is skewed, if n is 30, then it's close to a normal distribution. That's really neat. I think you'd like that. As a matter of fact, that's a very powerful idea in statistics. And then lastly, while you're working the problems, there's some kind of like plan, okay? What's the plan? First of all, make sure n is greater than 30. Find mu x sub r, sketch the curve, and find the area so you can answer the question. So we're going to go back to that problem in a moment to make sure that we do this exact procedure in that. All right, in your notes, what happened was somebody picked a die and they tossed it 3 times, and the numbers on the die go from 1 to 4. Well, what this is all of the possibilities of getting the die thrown 3 times, okay? You could think of 3 dies thrown 1 time or a die thrown 3 times in a row. And what we're doing here is we're finding the average. See, this is what x bar is, finding the average. Now, this chart is figured out in order, okay? So it's not like somebody sat there and found these out just by flipping. These are all of the possibilities. But what's neat about it is if you plotted the averages, you will get a normal distribution. That is really neat. So for a sample of 3 in this particular problem, theoretically, we would get a perfect what? A perfect normal curve. Okay, and again, that's very interesting. And then what we want to show you here is, let's just say I started with a distribution that was, this is definitely not normal. This is skewed to the right, right? Okay, and then here's all my probabilities here. If I took random samples of my variable right here, okay, and let's say I did sample size 3, I would get something that represents the parent pretty good, but sample 10, okay, notice what's happening to the distribution of the sample, right about 30. And again, what this looks like a normal distribution. Why is this important? The reason why this is important is we could apply what we've learned about the normal curve to a sample. That is just so cool. Let's go back to our problem and actually work it. All right, let's see. There's this question again, and question 1 says, for a group of 64, so n is 64, find the probability that the average, okay, right, percent of fat calories consumed is more than 25. All right, so here's our sample of 64, correct? Okay. Now remember, the mean is the mean of the population. So that was 36. Now we don't know what the standard deviation is right here, but one thing we do know, they want to know what's the probability of more than 25. And we know that 25 is to the left here. So it wants this area right here for the probability. All right, so here's our data here. Sigma x bar is equal to, there's a formula, 10 over, that's 8. 10 over 8, let's see, that would be 5 over 4 or 1.25. Okay? So what we're going to do is we want to know this area over here to the right. So we're going to go and use our normal CDF, and the lower is going to be 25, the upper is going to be 1E99, the mean is 36, and the standard deviation is 1.25. Okay, so I worked that out on my calculator and I got 0.99999, which rounds to 1. So we're 100% probability of getting that to work out that way. Find the first quartile for the average percent of the fat scores. I draw the picture again, okay? I know it's a little boring or whatever. All right, so I'm going to say this part right here is 25% or 0.25. So find the first quartile. It actually wants a value of my random variable. So I'm going to go inverse norm. Okay, I'm going to go 0.25, comma, the lower one is negative 1E99, number way to the left. We don't know, I done messed up here, so stop. Okay, I don't like messing up. Inverse norm, you have the percentage, then you need the mean. The mean we know is 36. Where'd my pen go? 36, and then the standard deviation now I'm going to use because it's talking about my sample, okay? I'm going to write that, and when I multiply that out, I will get 35.16. 35.16, what? Percent. Okay, we should really write the answer out in words, but that's what we're going to do right now. Okay, Mr. Staples, can you do a more difficult problem? Sure. All right, so here's question, it's one of the last questions. 1942, the average size of a U.S. farm was 174 acres. Let's say the standard deviation was 55. Suppose we randomly survey 38 farmers from 1940. What is the interquartile range? Now remember, the interquartile range is the 75 minus the 25. Here's my 75 number right here, okay, which gives us this number. And then here's my 25% number, which gives me this value. And what am I going to do with these two values? I'm going to subtract them, okay? And when I do that, I get the appropriate answer. Mr. Staples, what resources are available? Here's Unit 3. I'm going to put some information in here, so please go through here and click on things related to either the lessons or videos that may help you. That'll be a good thing. Okay, I had decided to put my key to my instructor's solution key, the problems I'm working out, put some of that material in there to the lesson so you could see that if you need that kind of help. So again, what I'm talking about, here's a little copy of my lesson 14 front side. So, you could see how I did the problems. Maybe that can help you out. Just like I did for a former video, to see how to use some of the keys in the calculator. Remember, you use this for finding the value under the normal distribution, and you use this to find the value of the variable given a percentage, okay? So here you're finding a percentage, and then here you're finding a random variable value. What advice could I give you for the quiz? Make sure you review your terminology. You're familiar with how to do the problems and understanding the question. You got to read the question carefully, then work the problem, and then do the calculation. So if you will just do that and practice that, you should be ready for the quiz. Good luck, and I wish you the best.